Hello students, today we will discuss about the periodic properties, which is the continuation of the previous class, the module number 1, and our lecture is 8. So today is the last lecture. Now we will discuss about the shielding effect, the effective nuclear charge, and also we will discuss about the orbital penetration effect, and we will calculate some of the oxidation state of the elements. So let's start the class.
So students, we will start today, that is periodic properties. Today our lecture number is 8 and the module is 1. So these are our objectives of the today's class. First of all, we will discuss about the shielding effect. Next, we will see what do you mean by effective nuclear charge. Next, what do you mean by penetration of orbital? That is orbital penetration. What does it mean? That we will see. And at last, we will see oxidation state. We will calculate some of the oxidation states of elements. Okay. So some of the compounds generally in exam, this type of questions you can have. Some of the compounds are there, and in that compound, one element you have to find out the oxidation state. So from the oxidation state, today we will calculate the oxidation state of some elements. Okay, how to calculate the oxidation state, that we will see first. So these are our objectives of the today's class. Okay, so these are the some of the topics that we have discussed in our previous class, that is polarizability, polarizing power, and Fusson's rule. Okay, so this is just at a glance whatever we have discussed. For your recapitulation, you can memorize again what are the topics we have told so far. So that is why I have given the topics name, the recapitulation of the topics name. Okay, polarizability and polarizing power and the Fusson's rule we have seen in our previous class. Now polarizing power, generally polarizing power and polarizability. This polarizing power is actually related to the cations. Okay, so the ability of the cation to distort an anion, distort the electron density of an anion, that is called by polarization power. That means what will happen if positive and negative ion will come to each other. What will happen that time? The positive charge will attract the electron density of the whatever the anion has on its so that electron will be distorted. Okay, this type of distortion will take place, and this distortion, the power of this distortion, the ability of this distortion is called by the polarizing power. And the polarizability, this is actually related to the anion. Polarizability, how much the anion is allowed to distort its electron, that is called by the polarizability. That means anion, that means the electron density on that element. Okay, so if in presence of positive ion, what will happen? Whatever the electron density it has, all the electron will come closer to the positive ion, attracted by the positive ion. So polarizability means the power, how much it will allow the electrons, its electrons, to distort towards the positive ion. This is called by the polarizability. And based on this polarizing power and polarizability, we can determine whether the bond is having the covalent character or the ionic character. If the polarizing power or the polarizability will be higher, that means the distortion, this type of distortion will be higher. That means that bond will have the higher amount of covalent character. Okay, The negative charge will become less negative after the presence of two ions. What will happen while the two ions will come closer? So negative charge will be less, positive charge will also be also less for this distortion, attraction force, and polarization. If the polarization will be more, that means it will increase the covalent character of the bond, whatever I have told you. So now Fazan's rule, according to the Fazan's rule, what will happen? The small cation, if the small cation we have, that means that cation has the higher polarizing power. That means that cation has a tendency to make the covalent bond more. If the anion will be large, for larger anion, what will happen? The electrons are loosely bound, and that is why the electrons can be distorted towards the positive ion more. So that is for this case, for larger anion, what will happen? We can expect that the bond character will be the covalent character. Obviously, the large charges, if we have the large charge on the cation, what will happen? Again, the polarizing power will be higher, and the distortion of the electrons will be higher, and covalent character will be higher. And one more thing, while if the cation, the electronic configuration of the cation, if it is the inert gas configuration, that time the covalent character will be lower, because the it is less for the inert gas elements, the ions, the it is they have the less tendency to attract the electron. Or if the cation will have the pseudo inert gas the configuration, that time the charge will be higher, distortion will be higher, and covalent character will be higher. Here you can see instead sodium chloride, magnesium chloride, aluminum chloride. So in between these three, aluminum chloride is the has a higher tendency to make the covalent bond. Again aluminum fluoride, aluminum chloride, aluminum bromide. Again the size of the bromine will be higher, and that's why the what will happen? The as the size will higher of the anion, that means the covalent character will be higher. And here you can see the size of the cation will lower. Sodium, in between sodium plus magnesium plus to aluminum plus 3, aluminum plus 3 is smaller than all these atoms, so that's why it will have the higher tendency to make the covalent bond. So these are the some of the statements of Fazan's rule, and already we have seen this. Okay, so now today we will see. So this is acha. One more thing. This is a quick review. Whatever I have told you, and now I am telling you. So based on that, how much you can remember? Based on that, I have to. I have given one question. The question is, in between sodium chloride and aluminum chloride, which one is more covalent? Okay, so for this you will have the 10-second time. Your time starts now. Yeah. Yeah. So your time is over, and obviously the aluminum chloride, yes, of course the aluminum chloride has a higher covalent character, higher tendency to make the covalent bond than the sodium chloride. Okay, already I have seen in the previous slide. Okay, next. So this is our today's topic, that is the shielding effect. So shielding effect, the term shielding effect refers to a decrease in attraction between the electrons and nucleus. Okay, so we have this is the nucleus, and around the nucleus we have the electrons. Electrons are revolving, right? So these electrons are generally attracted by the nucleus, right? So this attraction force. Now what will happen when additional electrons are present in different orbits? The electrons repel each other. Generally in between this electron we have the repulsion force as the they are having the same charges. Okay, so these repulsion force work against the nuclear attraction force. This due to this, excuse me, due to this repulsion force, what will happen, the attraction force, whatever the nucleus will attract this electron, this attraction force will be less. Okay, decreasing of the attraction between the nucleus and the electrons. The electron shielding effect mainly applies to the valence electron, whatever outer orbital electrons. So generally we consider the shielding effect for that outer orbital or valence electrons. Okay, the shielding effect explains why valential electrons are more easily removed from the atom, and the order of the shielding effect is s orbital greater than p orbital greater than d orbital greater than f orbital electrons. Now shielding effect, what is shielding effect? Look, so this is our nucleus. Around the nucleus we have the electrons are revolving, right? Now here what will happen, this is our outermost electron, right? So these outermost electron and also this is inner orbital electron also, they are both attracted by this nucleus. Okay, by this nucleus. Now what will happen, this electron, this inner orbital electron always has the tendency to shield this attraction force, so that in between this electron and the nucleus the attraction force will be lower. Okay, always the inner orbital electrons having this shielding effect, having this tendency to shield, to become a barrier. Okay, so that the outer orbital electrons cannot be attracted by the nucleus more strongly. Always this has the tendency. Okay, so whatever the inner orbital electrons, if we have 2 electrons, 3 electrons, 4 electrons, each and every electrons are having this same tendency, that is the tendency to barrier the attraction force the in between nucleus and the outer orbital electrons. And also this shielding effect will act in the same orbital electrons also. Like in this outer orbital also we have this, here one electron, here one electron we have. So these 3 electron both will repulse with each other, both will have the repulsion. Okay, and both having these 2 electrons, these 2 inner orbital outer orbital electrons again have the same tendency to become a barrier, to shield the attraction force, so that these the electron cannot be attracted towards the electron nucleus, or cannot be attracted by the nucleus more strongly. Okay, so same orbital electrons having the same effect, these effect actually called by the shielding effect. So the order of the shielding effect, that means the s orbital electrons are having higher shielding effect than the p orbital electron, then d orbital, and then the f orbital electron. So this is all about the shielding effect. Okay, now we will discuss about the effective nuclear charge. Look here. So due to the shielding effect, that means what will happen, the outer orbital electron, like this electron, look at the picture, this electron. Okay, so this outer orbital electron cannot be attracted by this nucleus, positive charge nucleus, so much strongly due to the shielding effect. So it will have a effective nuclear charge. Due to the shielding effect, it will experience a decrease in attraction force, which is called by the effective nuclear charge. Okay, the magnitude of the shielding effect is difficult to calculate precisely. As an approximation, we can estimate the effective nuclear charge. We cannot estimate how much the shielding effect is. Rather, we can estimate how much the effective nuclear charge of one electron, nuclear charge will experience for an electron. Okay, the effective nuclear charge, the Z effective, generally we indicated it by the Z effective. Okay, is the net positive charge experienced by an electron. Net positive charge. Why net positive charge? Because for the shielding effect, to some extent the attraction force of the nucleus will be lower for that electron, outermost orbital electron. Okay, in a multi-electron atom, the term effective is used because the shielding effect of the negatively charged electrons prevents higher orbital electrons from experiencing the full nuclear charge. Exactly. So this electron can never experience a full attraction force due to the presence of this electron, inner orbital electron. Look, this green zone here, we are having the electron density. Okay, so these are the electrons of the inner orbital electron, and generally these electrons are become the barrier in between this outer orbital electron and in between this nucleus. Okay, so that is why the higher orbital electrons from experiencing the full nuclear charge. Okay, so generally Z effective, that is equals to Z minus S. By this equation we can calculate the effective nuclear charge for a atom, for a element. Okay, so where Z is the number of protons, whatever protons we have in the nucleus, and S is the number of, mind it, S is the number of electrons between the nucleus and electron. So look here, whatever this is the outer orbital electron. For this electron, consider ki for this electron we are measuring, but we are determining the Z effective. So what we have to do, first of all we have to check how many the proton numbers are there, how many protons are there, that we have to check. Okay, and S, what is the value of S? S is, that means how many electrons are there. Instead of this electron, this outer orbital electron, how many electrons are revolving around the nucleus, that we have to first calculate, and that is the value of the S. Okay, yeah, so this is called Z effective. Okay, now next topic is orbital penetration effect. Orbital penetration effect, generally what will happen, the penetration describe the proximity of the electrons in an orbital to the nucleus. In a multi-electron system, electron penetration is defined by an electron's relative electron density near the nucleus of an atom. One S electron has greater electron density near the nucleus than 2p electron and has a greater penetration. Okay, now I'm telling you what is orbital penetration. Orbital penetration means like uh, around the nucleus, we all know कि we are having a positive mass, that is the nucleus, and around the nucleus all the electrons are revolving, right? So what will happen, the electrons are revolving in the s orbital, in the p orbital, in the d orbital, or it can revolve in the f orbital. Okay, now how much these electrons are interacting with the nucleus, how much is the proximity of this electron density to the nucleus, this is called by the orbital penetration. Orbital penetration means how much, this is your nucleus, this is your nucleus, and what will happen, around the nucleus the electrons are revolving, right? Now what will happen, the orbital penetration means this electron, the electrons that is revolving in different orbitals. So how much they are penetrating, interacting with the nucleus, how much they are proximity, what is the proximity of that electron density, okay, to the nucleus. This is actually called by the orbital penetration. Always 1s electron has a greater electron density near the nucleus, and the shape of the 1s electron, 1s orbital is sphere. Nucleus is also sphere, so obviously the penetration with the s orbital and with the nucleus will be higher. So 1s has the greater electron density near the nucleus than a 2p electron, and has a greater penetration effect. Okay, now the radial, this is the radial distribution. These are along the yes, along the x-axis this is r radius, and along the y-axis that is the probability of finding the electrons. Now the radial distribution function shows that the 2s orbital penetrates more deeply into the 1s orbital than does the 2p. Okay, the weaker penetration of the 2p sublevel means that the electron in the 2p sublevel experience more repulsive force, and they are more shielded from the attractive force of nucleus. Okay, the deeper penetration of the 2s electrons means the electrons, deeper penetration means higher penetration. Okay, so 2s electrons means the electrons in the 2s sublevel experience a greater attractive force to the nucleus and are not shielded as effectively. Now look, that means what will happen, if anyone's tell you कि for this orbital we have less penetration power, less orbital penetration power, that means what? Less orbital penetration, that means that orbital is less interacting with the nucleus. That means what will happen, the shielding effect, so that means the nucleus, whatever the electrons are present into that orbital, the nucleus is not holding the electrons that much strongly, so that means the shielding effect is high for that case. Okay, now for the deeper penetration for the 2s orbital, here you can see one that is the deeper penetration of the 2s electron. That what does it mean? That mean the 2s electrons are interacting with the nucleus more. That means the attraction force for these orbital electrons are more. That means shielding effect is less. Understand? So these are the two statements that is very important. Okay, to understand, and you have to understand this, otherwise you cannot get the concept of orbital penetration. Generally orbital penetration is the interaction with the nucleus, how much the electrons are interacting, how much the electrons are attracted by the nucleus. Okay, the result is that the electrons in the 2s sublevel are lower in energy than the electrons in the 2p orbital. Okay, the penetration is not the outer electron penetrating through the shield of the core electrons. It is actually just how well the exactly penetration is not like that ki outer orbital electron is shielded by the inner orbital electron. Notice that that is not the penetration. Penetration mainly what does it mean? Generally that orbital electrons, how much their proximity to the nucleus, how much they are interacting with the nucleus. Okay, since core electrons do not shield themselves. They penetrate the most and are exposed to the most nuclear charge. Exactly. The inner orbital electrons are interacting with the nucleus more. That is why for that the penetration will be higher. The order of the shielding effect as well as the order of the orbital penetration effect is the same, following the same order, that is s orbital greater than p orbital greater than d orbital, approximately similar to the f orbital. D and f hoche approximately similar. Okay, so this is all about the orbital penetration effect. Now this is a quick review. I have given one question, that is for neon, what is the effective nuclear charge for the valence electron? Yes, effective nuclear charge, already you know the equation. Now you can have this type of question. Some of the elements will be given, and for that elements, for the specific electrons that you have to calculate what will be the Z effective for that electron. Okay, so for this you will have the 10-second time. Just memorize whatever taught today and answer the question. Try to answer the question. Yes, your 10-second time is over. Now have a look at the answer. Yes, neon has 10 electrons, inert gas element. So what is the configuration? That is 1:2 to 2p6. So we have to calculate the effective nuclear charge for the what? Valence electron. That means for this electron 2s to 2p6, the for this 8 electron we have to find out Z effective. Now the Z effective, already you know, Z minus X. Z is the number of proton. So here the total number of proton is 10 for neon, right? Now for valence electron, what will be the S? S means the valence electron. Rather than the valence electron, how many electrons are there, which is which can make the shielding effect. Okay, so here 2 electron, 1:2 only. This 2 electron can shield the these 8 electrons, right? So that is why 10 minus 2, so 8 plus. So this is the effective nuclear charge. This type of questions you can have, right? Okay. Next, oxidation state. There are some oxidation rules of calculating oxidation state that we have. Generally from this portion you can have this type of question ki the elements are given. So for that element you have to find out ki what is the oxidation state. Okay. So rule number 1, any individual atom and combined with other elements has the oxidation state 0. That means if we are telling silver, that means for silver it should be the 0. Sorry. Rule 2. The total sum of the oxidation state of all atoms in any given species is equal to the net charge on that species. Okay. Next is in neutral species, the total sum of the oxidation state is the sum of the all atom. In ions, the total sum of the oxidation state is the charge of the ion. Exactly. So rule 4, the oxidation state of fluorine is -1 in a compound. So fluorine is -1 in HF or SF6. The oxidation state of hydrogen is +1 in a compound. The oxidation state of oxygen is -2. These are all you have to memorize. Okay. In 2 electron compound with metals, group 15 elements, state of 3 have the oxidation state. Okay. So these are the some of the rules that you have to follow, and otherwise you can't get the calculate the oxidation state. Now we will see what will be the oxidation state. Find out the oxidation state of chromium in chromate CrO4 -2. Okay. So from rule 2 we know that the sum of the oxidation state for this compound is 2, right? Minus 2, sum of the this is sum of the minus 2. So from rule 6 we know the oxygen in a compound is minus 2. Since we have 4 oxygen, so that means to minus 2 into multiplied with 4, that is equals to minus 8. Yeah. Next we will see. So chromium, we have to find out the value of the chromium, plus minus 8, that is for the oxygen, that is equals to minus 2, right? So chromium is ultimately 4. So thus you can calculate the oxidation state of any element if you are given one compound. This type of question you will have. Next, find out the oxidation state of carbon in this compound. So here we have to follow the rule number 2, rule number 5 and rule number 6, and from that we can. So 2 carbon atoms we have. Look here, 2 carbon atom. Rule 4, 2 and 6 we have to find out. So 2 carbon atoms are there, 3 hydrogen atom, and oxygen minus 4, minus 2 into 2. So minus 4, that is equals to minus 1, right? So that means 2C carbon equals to what? 0. Yeah. So that means C equals to 0. Oxidation state of the carbon is 0. Next question, find the oxidation state of sulfur in this compound. Okay, now this thing you have to do by yourself. Your time starts now. You will get the 10 seconds. Very easy. Yeah, your time is over. Now we will see. Look. So again 2 is sulfur, there are 2 atoms are sulfur and 3 oxygen atoms. So 3 into 2, that is 6, minus 6. So sulfur is actually 2. The oxidation state of the sulfur is actually 2. Why it is minus 2? Because here we are having the total as a whole, the compound is minus 2 charge. It is carrying the minus 2 charge, that is why. Okay, so these type of questions are very common. You can have this type of question from this portion of the periodic table. Now this is the end of the chapter. After this we will discuss all the questions, what are the types of questions that we can have, that we will discuss. So this is again I'm repeating the topic whatever I have discussed today. So we have discussed about the shielding effect. We have seen what is effective nuclear charge, and also we can calculate the effective nuclear charge. The penetration of orbital also we have seen what does it mean, and we can calculate now the oxidation state. So yeah, checked. So just students, please follow the classes regularly, as because this is the end of the chapter and we will discuss the questions. So first of all, you have to read the study materials and follow the classes well. Otherwise you cannot have the clue how to answer the questions. Okay, so thank you students, have a safe day.